All right. Hi, guys. We are doing the last lesson in Chapter R today. So please title your notes Lesson R3. And today we are learning about the properties of real numbers, seeing that we have been learning all about what it means to be a real number. Okay. So like I said, this is the last lesson in Chapter R. It's a pretty short and sweet lesson. So next class, we will do your Chapter R review. And then next week, you guys will take your Chapter R test. So please make sure you're taking great notes as you watch this video. Also, please make sure that you are checking your homework. You hopefully saw on Friday, I posted the homework solutions for R1 and R2 on Google Classroom. And myself and Miss Kinsey, your UCCS TA for this class, she's been making comments as well as I have been making comments on your guys' work. But please make sure you go through and check every single answer of yours. That way you know what you're understanding and what you might need to get help on. So email me if you have any questions on that. Okay, for your warm-up today, I would like you guys to go ahead and pause the video and try to write in your own words a definition for these 4 subsets of real numbers that we talked about last class. Feel free to use your notes again. That is what they're there for, and that's why I want to make sure you guys are taking really good notes. Okay, so integers, I would write the integers as something like all positive and negative whole numbers. Okay, for instance, -2, -1, 0, 1, 2, etc. in both directions. Okay, the real numbers, that's what we've been talking about the last couple classes. So the real numbers are all rational and irrational numbers. And remember, when you look at the diagram that we made, it's the big box or the circles that have all of the subsets that we learned about last class. The rational numbers were on the left side and the irrational were on the right side. These were rational, irrational. Okay, and then these all were underneath the umbrella of real numbers. So all of those were included. Okay, rational numbers, you could write that as any number that can be written as a fraction, or you could write it something like this as a divided by b, where a and b are just numbers. Or you could say any terminating or repeating decimal. Any of those definitions is perfect. Okay, and then whole numbers. These are the positive counting numbers, including 0. Okay, so 0, 1, 2, 3, etc. So no decimals, no fractions, none of that. Also, another thing to note for the real numbers, which is, again, what we're talking about here, all of these are real numbers. There's a symbol that we use to just write that a little bit more quickly. It's a capital R, but with an extra line in it. Okay, and if you have the set of all real numbers, you would write that just in set notation with the all real numbers symbol there. So that's just a little bit simpler, kind of a quick way to write it. Okay, today we are going to learn about properties of real numbers. There are 5 properties. A couple of them have multiple parts and pieces to them though, and all of these are properties of real numbers, what we've been talking about. So no imaginary numbers, nothing that involves I, okay? And all of these are probably things that you guys use every single day. You've used them up until this point in math, but you just haven't known what they're formally called, okay? The commutative property, there are 2 parts of it. There's the commutative property of addition. We'll learn about that in a second. And there's the commutative property of multiplication. Okay, same with associative property. So there are 2 parts, addition and associative property of multiplication. Distributive property, that's just its own thing. Okay, just one of those. And then identities, there's the identity property of addition again, or multiplication. And then same thing with inverses. There are two of those properties, addition or multiplication. So I didn't want you guys to feel like you're being deceived, that there are more than just 5 properties here. I mean, there are 5, but several of them, except for the distributive property, branch off into 2. Okay, and then the other thing to know is that we're only talking about addition and multiplication here. So these properties only work for addition and multiplication. You'll notice there's no subtraction, there's no division, none of the other properties. These will only apply for those specific cases. Okay, so the first property, commutative property of addition and multiplication. So the first part, I'm going to call it part A, is the commutative property of addition. It's kind of a mouthful to say. And then the second part is multiplication. So the commutative property tells you that 2 numbers can be added or multiplied in any order without affecting the result. Okay, so let's look at a couple of examples when we're looking at the commutative property of addition. This is something, again, you've probably used your entire life in math. You just haven't formally known that it's called this, likely. So that's really the point of college algebra, is this is the time in math when we're actually going to formalize things. We're going to give definitions to things, and you'll learn more of the wording behind everything you've already been doing. So you all probably know 2 plus 3 is 5, which is the same thing as 3 plus 2, okay? That order does not matter. And then algebraically, the way that we could write this is some number, a plus b, is the same thing as b plus a. The order can be flip-flopped, okay? And you're going to see this in both forms, where you have actual numbers and where you have variables. And it's important, again, in college algebra, we're starting to formalize things in general, so it's important to be able to recognize both of these, okay? Commutative property of multiplication, same thing, but with multiplication, so the order doesn't matter. 6 times 7 is the exact same thing as 7 times 6, or a number times a number, a times b, is the same thing as b times a if you flip-flop the order, okay? The way that I like to remember this, I look at commutative, the word that is hard to say, and I look at the fact that there are 2 m's right here in the spelling, okay? If I were to flip-flop the order of those m's, nothing about the word or how I pronounce it or what it means is going to change. So that's how I always remember. You can flip-flop the order of any 2 numbers, and that's important. It's 2 right here, 2 m's, of any 2 numbers when multiplying or adding. Okay, and I'm just going to abbreviate that. All right, associative property of addition and multiplication. So again, here's the first part, addition, here's the second part, multiplication. So the associative property tells us that you can group together quantities in any way without affecting the result. So it's very, very similar to the commutative property, but now we are talking about when you have 3 or more numbers that you can change their order. Okay, so when we look at the associative property of addition, that means we can add 3 numbers in any order and it's not going to affect the result. So, for instance, I could add 2 plus 3 plus 4 in this order where I group it by parentheses and I add the 3 and the 4 first. 3 plus 4 is 7, so 2 plus 7, okay? Or, over here, I could group the 2 plus 3 first, which gives me 5. And then I could add the 4. And in both cases, I get 9 on either side. Okay, so that works. So you can flip-flop the order. All right, same thing here with the variables. You can have 1 on the outside and group the other 2 first, or you can group the first 2 and then the other one on the outside. And when you're adding them, it's not going to change anything about the result. Okay, the associative property of multiplication, very similar. Now you can have 3 or more numbers that you're multiplying in any particular order. So I can multiply 6 times 7 times 8 and multiply the 7 times 8 first. That's going to give me the exact same thing as 6 times 7 first, and then times the 8, okay? Or same thing here algebraically. So remember, when we write two variables next to each other like that, that means we're multiplying them. And when you write it outside of parentheses, that means you're multiplying. So this is just grouping them differently, okay? But same result in the very end. So the way that I like to remember this, again, this is the exact same as the commutative property, except the commutative property is just two numbers, okay? So you can change the order of adding or multiplying two numbers. For associative property, it is when we're talking about 3 or more numbers. So 3 or more numbers that you're adding or multiplying, you can change the order. The way that I remember that is by looking at the word associative, okay? And if you notice, there is a 3-letter bad word in there. I'm not going to say the word. You guys all can see it. It also means donkey, okay? So it's not necessarily always bad. But that 3-letter word reminds me, okay, I'm talking about 3 or more numbers whose orders can be switched around. All right, distributive property. This is probably the one that you guys are most familiar with. And this, we just have one property for. So it lets you multiply a sum, which means adding, by multiplying each part of it separately and then adding the properties. Okay, so if we look here, here's an example of distributive property. I have 2 times 3 plus 4. So you might think, because of order of operations, I have to do what's inside the parentheses first, which is normally correct. So you would do 2 times 3 plus 4 is 7, and then 2 times 7 is 14. But what the distributive property says is that you can also distribute this 2 from the outside into the inside because there's a plus sign here, okay? And you can multiply each part separately. So you could do 2 times 3 plus 2 times 4. 2 times 3 is 6, 2 times 4 is 8, and 6 plus 8 is 14. Okay, so that gives you the exact same thing as if you did order of operations with the parentheses first. And then algebraically, same thing here. We've got a letter on the outside, 2 on the inside. You could multiply A times B and then A times C. So because this is a property of the real numbers, this works and it applies if you have a variable. So if you have, let's say, 5 times x plus 8, assuming that this x is a real number, you can distribute the 5 inside the parentheses to get 5 times x, the first term, and then 5 times 8, which is 40, and then be done. Okay, identity property. So the additive identity, or the identity property of addition, is the first one. And then we have the multiplicative identity, or you could call it the identity property of multiplication, either one, okay? When you think of the word identity, I want you to think identical. That's what's going to help you remember this. So here is what the additive identity means, okay? The number 0 is called the additive identity, since when it is added to any real number, it preserves the identity of that number. Okay, so what we mean is the additive identity is what you have to add to a number to get the identical number. Okay, you have to add it to get itself. Well, 0 is the only number in the world that you can add to another number to get itself. So 6 plus 0 is 6. A number plus 0, any number plus 0, is that same number. Okay, so with the additive identity, think again, identical. If you're wanting to add a number and get the identical number you started with, the only number that does that is 0. Similar for the multiplicative identity. That's kind of a hard word to say. You should practice saying it out loud. Your parents or your siblings will think you're kind of weird or cool, whichever one. Okay, multiplicative. So the multiplicative identity, we say, is the number 1. And the reason it's the number 1 is because when it multiplies times a number, it gives you the identical number back. Okay, 1 is the only number that does that. So when I multiply 6 times 1, what do I get back out? I get 6, the identical number I started with. When I add any number, or take any number and multiply it times 1, I get the same number, the identical number that I started with. So the multiplicative identity is when you multiply to get the identical number. Okay, so again, think identity, I want the identical number. So to add and get the identical number, it has to be 0. To multiply and get the identical number, it has to be 1. All right, and then the last one here is the inverse property. So we've got the inverse property of addition, or the additive inverse. And we've got the inverse property of multiplication, or the multiplicative inverse. This is what students most often get confused with the identity property, okay? So that's why I keep trying to give you guys clues of identity means identical, etc. Inverse property, I want you guys to think of reverse, okay? When you think of inverse, think of reverse or undo. Because if you think about an inverse function, that's what it does. It undoes whatever was being done before. Okay, it does the opposite and backwards. So the additive inverse is when two numbers are added together to get the additive identity of 0. So basically think of, how do you reverse or undo a number? How do you kind of cancel the number that you're starting with? Well, if I have -3, what do I have to do to undo -3? What do I have to do to reverse it? Or what do I have to do to cancel it? Well, I'd have to add 3, okay? And that gives me 0. So any number, when you add its opposite number, you're going to get 0, which is the additive identity. So for the additive inverse, you're wanting to do the opposite. You're wanting to add the opposite to undo it. So let's think about, if you have the equation x plus 8 equals 9, and you want to solve for x. Well, you subtract 8 from both sides. That cancels the 8. Okay, this right here, this is the additive inverse. You just undid what the positive 8 did. You canceled it, okay? So it's, what number do you have to add to quote unquote cancel the number, okay? And then the multiplicative inverse is what number you have to multiply by to get the multiplicative identity. So we said the multiplicative identity is 1. The additive identity is 0. The multiplicative identity is 1. So here you have to multiply a number by its reciprocal. Reciprocal. So multiply to get 1. Okay? The reciprocal is the opposite numerator and denominator, or flip-flopped numerator and denominator. So if I multiply 5, which is the same thing as 5 over 1, by 1 over 5, it's reciprocal, that's going to give me 1. Okay? That'll undo the number and give me 1, the multiplicative identity. Any number multiplied times its reciprocal, so like a times 1 over a, is going to give you the multiplicative identity of 1. Now, let me show you one other example. Let's say we take 2/3 and I want to find the multiplicative inverse. The reciprocal of 2/3 is 3/2, and that gives me 1. Okay? And I show you that because this example was a whole number to begin with, but remember, every whole number can be written as a fraction over 1. Okay, so make sure, again, for inverse property and identity property, you're really taking good notes and trying to remember, okay, inverse, I'm trying to reverse or undo or quote unquote cancel the number. Okay, what can I do to get rid of it and to get 0 when I add or to get 1 when I multiply? Identity, we're looking for what can I do to get the identical number. So these are your properties of real numbers. And just really quickly before I end the video, I'm going to show you guys or explain to you how to start your R3 homework. So I'll go through a part of each section. Okay, so the first section wants you to find the additive inverse of each number. So additive inverse, okay, remember inverse, we just talked about this. We're trying to reverse, we're trying to get 0 as our result. So here's an example. If I give you negative 12, the additive inverse of that is 12 because negative 12 plus 12 gives you 0. So for instance, 15 on number 1, the opposite of that would be negative 15. 15 plus negative 15 would give you 0. Okay, part 2, you're wanting to find now the multiplicative inverse. So you need to find what do you multiply by to get 1. So an example, 1/2. The multiplicative inverse of that would be 2 over 1 because remember you take the reciprocal. So when you multiply 1/2 and 2, you get 1. So think reciprocal. Okay, so like number 8, that one, this I'm going to write as a fraction. Negative 27 is the same thing as negative 27 over 1. So the reciprocal of that would be negative 1 over 27. You do not get rid of that negative because we're no longer talking about the opposite. Like up here for addition, we are talking about what do I multiply by to get 1, which is the reciprocal. Okay, section 3, you are not solving anything here. You are just listing the property that you see happening. So here's the word bank right here up at the top for you guys to reference, okay? And here's an example. So if I give you this equation, 43 plus 25 is the same thing as 25 plus 43, you need to tell me what property that is. Well, look at what happened. Their location or order swapped, okay? How many numbers am I talking about? I'm talking about 2 numbers. So this is the commutative property of addition. Because the 2 numbers, their order swapped, we're adding it. That is the property you'd list. All right, this page, this top section, same thing, lists the property. And then the last section here, you are going to use the indicated property to complete the blanks. So here is our example. If I give you this blank of negative 15 plus something is something, and I want you to use the additive identity, then I know identity, okay, that means identical. I need to get the identical number over here on the other side of the equation by adding something. So what do I have to add to negative 15 to get negative 15? 0. And then I'd complete the blanks there. All right, so you'll fill out the blanks here by referencing these properties over to the side. And I by no means am expecting you guys to have these memorized today. This is the very first time that you're seeing it, and that's why you guys have your notes. So let me know if you have any questions, and we will go over additional questions when we Zoom.